This is an explanation of some proportions in triangles. We have this triangle here, the big triangle, and we cut across it with this segment of length P, which is parallel to this bottom side. And because these are parallel, this angle on the left is congruent to this one because they're corresponding. These angles are congruent. Of course, this angle is congruent to itself. So basically, the upper triangle is similar to the big triangle. And so because of that, you can set up proportionalities. One of which is that A over B is equal to C over D, which is not equal to P over Q. It's important to note. If you want to think of it in terms of find one for P over Q, you have to think of the little triangle here and then the whole big triangle. So if you want to do little over big, you say A is the little left side divided by A plus B, which is the big left side, which is equal to C, the small right side, divided by C plus D, the big right side, is equal to P, the small third side, divided by Q, the big third side. Now you can extend this idea of the two parallel lines to multiple parallel lines. So that's what we have down here, where we have a bunch of parallel lines and A, B, C, X, Y, Z. And so you just match things up. A over B, so this over this equals X over Y. It's just a matter of corresponding pieces. X over A equals Y over B, as long as things match up. A over C, so top and bottom equals X over Z, top and bottom. B over Y, so left to right equals C over Z, left to right. B plus C over C equals Y plus Z over C. So this is one set of proportions that we can set up, parallel lines. Another type comes from what's called the triangle angle bisector theorem. If you have an angle bisector, then it splits this third side into two pieces, and all this says is that the left side over the left side of the bottom is equal to the right side over the right side of the bottom. So A over X equals B over Y. This can be written different ways. X over Y equals A over B. These proportions are equivalent to each other. So left over left equals right over right. And so here's some practice with those concepts. Okay, so the easiest way to do this is to draw on it. So we say AD, this is number 1, divided by DG is equal to something over EH. Well, what's missing? Obviously, what's missing is this one in here, which is BE. So the answer would be BE. Okay. For number 2, we say CF, so that's here, divided by BE is equal to FI, what's missing, EH. Okay. Now notice also that this angle is congruent to this one, so we also have an angle bisector. That comes into play here. So JA divided by JB, no, actually not J, JA divided by JC, so left divided by right is equal to AB divided by, so left divided by right, what's missing, BC. So when you draw it out, it's generally pretty clear what you have to fill in. JF, which is over here, divided by FE, so this is again the second one, the triangle angle bisector, is equal to something over DE, well, what's missing, clearly JD. And 5 and 6 are going to work in a similar way. Moving down to these problems. This is the second one, triangle angle bisector theorem. So 6 over x equals 9 over 8. 9x is equal to 48. If you cross multiply, x is 48 divided by 9, which we can reduce to 16/3. Over here, 1 divided by 2 equals 2 over x. This is the first one where these are parallel, so this is the side splitter theorem it was called. Cross multiply, you get x is 4. This is back to the triangle angle bisector theorem, so x over 10 is equal to 10 over 8, so 8x equals 100. Divide by 8, x is 12.5. This is back to the triangle angle bisector again. 5 over 4 equals x over 3. Multiply by 3 if you don't feel like cross multiplying, and you get 15/4. And then let's skip 13, 14, go down to these ones that have some algebra in them. X over 6 equals x plus 1 over 9. this is related to the side splitter thing on the first page. So I cross multiply 9x, 6x plus 6 because I need to distribute the 6. Subtract 6x, divide by 3, I get x is 2. And then this last one over here, x over x minus 1 is equal to x plus 4 over x plus 2. I cross multiply. And I'll have x squared plus 2x is equal to x squared plus 4x minus x minus 4. You have to remember the inner and outer terms. I can cancel off x squared, so I've got 2x is equal to 3x minus 4 because 4x minus 3x is minus x is 3x. And then I'll divide by, let's see, 4x equals 3x minus 4. That's what I need. I will add 4 to both sides and subtract 2x. And so 3x minus 2x is just x, so x is equal to 4.